All right, so we are on, okay, 4.4, which finishes up this unit. And we're going to be discussing two different topics: relative rates and what is called elasticity of demand. So we're going to start out this section with relative rates. Whoops. E. And relative rates is used a lot in economics. And so what we're going to be talking about is what is called relative rate of change. Now, just for future reference, I don't want to have to write this out over and over and over. So I'm going to abbreviate. And when we're calculating the relative rate of change, I'm just going to call it RRC. And we're going to be finding the relative rate of change of a function. And that is found by the derivative of the function divided by the function. Now, that should look familiar. The natural log formula, when you're finding the derivative, was the derivative over the function. And if you'll notice relative rate of change, it shows that as well. All you need to know to do is to find the relative rate of change by taking its derivative over the original function. Now, we'll eventually be given a function and have to find its derivative. But before we do, I want to show you why this is used. So I'm not going to give a particular function, but I'm going to tell you what the function represents. And it represents the cost of a bottle of wine at T years. So the cost of a bottle of wine at 5 years, at 10 years, and so forth, because supposedly it's supposed to, the older a wine gets, the higher in value it goes. So typically we would be given the function and we would input and then find an output. I'm going to give you the input and the output. So let's say that we're given f of 3. So this would represent the cost of a bottle of wine at 3 years. And that output is $26.50. So this represents, at 3 years, the bottle of wine is worth $26.50. And I'm going to give you the rate of change, or I'm sorry, yeah, I'm going to give you the derivative, basically, not the relative rate of change, just the rate of change, the derivative at 3. And that is going to be given as $10. Now, just to remind you what that means is, at 3 years, the price is increasing at a rate of $10 per year. So we know it's increasing because that's a positive 10. If it would have been a negative 10, we would have said the price is decreasing at a rate of. So what the first derivative tells us is that each year, that bottle of wine should increase in value $10. So at $26.50 at 3 years, that would mean then at year 4, it should increase $10 more, which would be $36.50. And then the next year, it would increase $10 more, and so forth. Okay. All right. So then what we're going to do is do a comparison with that. So now what I'm going to do is I'm going to give you F of 3 for a different bottle of wine, and instead of being $26.50, so this one at 3 years, this bottle of wine is worth $265, a lot more expensive. And that rate of change, let's say, is also $10. So what this is saying is at 3 years, the price is increasing at a rate of $10 per year. So that's the same here. So the next year, this would be $275 and then $285 and so forth. Okay. So different initial values at 3 years, but the price increase per year at a rate is the same. So if I said, here's 2 bottles of wines, if I had those here and you didn't know the price, and I just said, okay, here's 2 bottles of wine. This one is going to increase $10 each year. This is going to increase in value $10 each year. You go, oh, one bottle of wine's not different than the other. Okay. So this is where we use a comparison of relative rate of change, okay, because we know they're both increasing at $10 per year. So what we're going to do is we're going to find the RRC of both because this is a better comparison. And let me show you why. So let's talk about the first bottle. So the RRC, relative rate of change, is equal to the derivative over the function. And I'm looking at, 3 years. So those were given. So this was $10. This was $26.50. Whoops. All right, so if you do $10 divided by $26.50, you get 0.37736. Move the decimal. So we're looking at 37.736%. So the actual monetary value is it's increasing $10 per year. If you look at that as a percentage, we're saying it is increasing at a rate of 37.7% per year, as opposed to the second bottle of wine. If we did the same calculation, but the initial, which the $10 is the same, but this is 265. So if you take 10 divided by 265, you get 0.03774, which would be approximately 3.774%. So when you compare their relative rate of change, yes, this bottle of wine, the initial value is only worth $26.50, but each year its relative rate of increase shows you that it's increasing at a faster rate than the second bottle of wine. So that's why we look at RRC. Now, another area that you will look at this with, and it becomes beneficial, is when you are looking at the GDP. Now, GDP is something that you'll hear political officials talk about a lot. It's the gross domestic product, and that is your total value of goods produced and services provided. And so you'll hear that in economics and political realm because they always want a good GDP. Okay, so the GDP T years from now is predicted to be 8.2 e to the square root of t. Now, this is given in trillion of dollars. So if you did an input and your output is 5, that doesn't mean $5, it means $5 trillion. Okay, so you may be asked, find the RRC in 25 years. All right, well, before I can plug in 25 years, I first need the RRC. And we know that to be, and in this case, it would be the derivative of the function over the function. So that tells me I need to find the derivative of this first, okay? So we're gonna find the derivative. Oh, but wait, before I find the derivative, I'm gonna pause. Why? Because I am going to rewrite this as t to the 1/2. So all I'm doing is rewriting the original function. So it's going to be 8.2 e to the t to the 1/2. Now we're going to take the derivative. So the coefficient in front just stays 8.2. Now we're going to take the derivative of e raised to the t to the 1/2. So when you have base e, if you go back to the formula sheet, it says first, just leave it alone, times the derivative of the exponent. So that would be 1/2 t to the negative 1/2. Okay. So now what I'm going to do is I'm going to clean this up a little bit. So we have 8.2. I can multiply that times 1/2. We have e to the t to the 1/2. And since this has a negative exponent, I'm going to bring it to the denominator. So then if you multiply or you take half of 8.2, you're going to get 4.1 e, and I'm going to rewrite this as the square root of t all over the square root of t. So this is my first derivative. So I'm going to have to place all of this in the numerator in order to find the RRC. All right, so now we're going to find the RRC, which is the first derivative all of that over the original function. Okay. Now, this goes back to dividing fractions. If you remember, leave the numerator alone. Looking at the denominator, this is all over 1. And so you change this to multiplication and you flip-flop or take the reciprocal, which would be 1 over 8.2 e to the square root of t. So now we look at this and go, okay, how can I simplify? Well, these two cancel each other out. And then if I take or simplify 4.1 and 8.2, that is gone. 8.2 divided by 4.1 is 2. So in essence, what we're left with in the numerator, we're left with 1. And in the denominator, we're left with 2, the square root of t. So it ended up pretty nice fraction here from what it started with. So we have found the RRC. This particular problem said, okay, now that you have the RRC, let me know what that is at t equals 25. So we're going to take the RRC, and in place of t, we're going to put 25. Well, we know that the square root of 25 is 5. So we get 1 over 10, and RRC we look at as a, get this straightened, we look at it as a decimal and then a percent, 1/10, so this would be 10%. So since this is positive, we know we have an increase, 10% per year. So the GDP is going to increase at a rate of 10% per year. All right, so that's relative rate of change. So the other topic in this section, to finish out Unit 4, elasticity of demand. Now, this topic, what this deals with is how price changes affect the quantity of items sold. So what I think of is Walmart and the rollbacks. Why do they have rollbacks in their prices? They'll show you a product and they'll say there's been a rollback of, it used to be $5 and now it's $3.50. So a rollback is they reduce the price. So that's a price change that they reduce. Why do they do that? Because they're hoping to sell more items. So if they reduce the price, they're hoping the quantity of items sold goes up. Now, typically we think, well, then always you're reducing prices. Well, not always. Sometimes you can look at and you can raise prices, but you have to be careful because you don't want to raise them so high that people say, I'm done, I'm out, I'm not buying anymore, right? But you can raise it and people will still purchase it. Here's an example. I like white chocolate mocha coffees at Starbucks. I typically get a venti, which is the largest one, which I shouldn't, but the price of that was like $5.75, and it just recently went up to $5.95. So that price change went up. Well, it hadn't quite hit enough that I'm still not willing to buy it. Now, if it goes over $6, I might go, yeah, nope, I'm out, not doing it anymore. So there's kind of a sweet spot at what is the price that I can sell it for to get my maximum revenue where I'm not knocking out customers to where they won't purchase it anymore, okay? So we're looking at revenue, which, if you recall, that is the price of the item times the quantity sold. So what I talked about is, so in my Starbucks example, the price went up. Okay, so what they're considering is, if we raise the prices, will we lose some customers? Maybe. But if we don't lose a lot, the increase in the price is going to offset maybe a few lost customers. But if we lose a bunch of customers where they won't buy it anymore, then we have to rethink our decision, okay? Whereas my Walmart example, rollbacks was decreasing the price. If I decrease the price, will I sell more? That's what they're hoping for. How many more? Is it worth the loss in revenue? So those are the things that companies consider when they're looking at any price change. So ultimately, what we will look at is what is called E, which is your elasticity of demand. And that is the percent change in demand over the percent change in price. Now, this isn't the actual formula we'll be using. I'll show you that here in a little bit. But what we need to really look at is the results of what E tells us. That's what we're most interested in. What are the results? So there are 3 different possibilities. When we calculate E, if or when E is a value that is greater than 1, then we consider that as being elastic, meaning there's lots of give we can have in the price. Okay, so it's very elastic if it's greater than 1. So what does that tell me to do? If it's elastic, it tells me to go ahead and lower your prices. So this would be like a rollback. If that elasticity greater than 1, hey, we can lower the prices, which should induce people to purchase more of them. The second result is when your E is less than 1. We call this inelastic, so not a lot of give, and we can look to raise the price here. And so that would be an example of like my Starbucks example, okay? And then the third one is when E is equal to 1, and this is what we call unit elastic, which means we're right where we need to be. This is kind of your sweet spot. And it's considered that because your revenue is maximized. Now, this wording you need to pay attention to because WebAssign or on a test it might say, when is revenue maximized? Well, you have to know that means then your elasticity of demand is equal to 1. All right, so let's get to the formulas we're actually going to have to use for the functions, I guess I should say. All right. So we first need to talk about the demand function. This is the demand of something is solely determined by the price of the good. Okay. The demand of something, so our function is when the demand of something is solely determined by the price of the good. So you'll be given a demand of P, P being your price, equals X. This is your number of units demanded that will be bought at that price. Okay, so now we're going to get to the function that we will help calculate E. And that, and again, remember P is price, and that is negative P times the derivative of the demand function divided by the demand function. So this right here is what we watch for, because that's going to give us E. And then we have to look at, what is E? Is it greater than 1, which means it's elastic, so we lower prices? Is it less than 1, which means it's inelastic and we raise prices? Or is it equal to 1, which means that's where our revenue is maximized and it is unit elastic? So that's what we're looking for. All right, so let's take a look at an example applying this. So we're given the demand function is 81 minus P squared. So let's say you're asked to find the elasticity of demand. So it won't probably say this, it will probably say find the elasticity of demand. So that tells us we are going to find E of P. So we're going to find this. So when I look up here, I go, I need to find the derivative first. So we're going to find the derivative of, I'm going to look at this and find its derivative. Well, the derivative of a constant is 0. So we would get negative 2p. So then to find my elasticity of demand, it is negative p times the derivative of the demand function. So in this case, that's negative 2p divided by the original demand function, 81 minus p squared. So I'm just going to clean the numerator up. We know a negative times negative is positive, and then I have positive 2, p times p is p squared. So I have 2p squared all over 81 minus p squared. Do not cancel these p squareds. I can't, because this term is married to the 81. The only way I could do that is if 81 had a p squared as well, and it does not. All right, so this is what I'm going to use to find my elasticity of demand. So have that, I think I can get part B on here. All right, so let's say part B. So find the elasticity at P equal to $3, $6, and state the results. All right, so I'm going to use this right here. So elasticity at $3 would be 2 times 3 squared divided by 81 minus 3 squared. So you would get 3 squared is 9, 9 times 2 is 18, 81 minus 9 is 72. So this is 1/4, which is 0.25. All right, so this is what helps us with our results. So if I am stating the results, this is obviously less than 1. Therefore, if it's less than 1, it's inelastic, which means we need to raise prices. So this is inelastic, tells me to raise my prices. So maybe Starbucks did this when they raised the price of my coffee. All right, so if we do it at $6, it would be 2 times 6 squared over 81 minus 6 squared. So we'd have 36 times 2, which is 72, 81 minus 36, which is 45, and that gives us 1.6. All right, so your results here, well, my E is greater than 1. Therefore, greater than 1, it's elastic, which tells me to lower prices. Okay. All right. One last question. It's still on this same example. Let's say part C asked us to find the price that will maximize revenue. All right. So when I started talking about this topic, I said, pay attention to this wording, because what does that wording tell me? When revenue is maximized, then I know elasticity is going to be equal to 1. All right, so we found elasticity function to be 2p squared over 81 minus p squared. So in order for it to be maximized, then we know this needs to be 1. So I'm going to rewrite it as 1 equals 2p squared over 81 minus p squared. Now it's a matter of solving the equation for p. So what I'm going to do is I'm going to write this 1 as 1 over 1, and I'm going to cross multiply. So I get 81 minus p squared equals 2p squared. I'm going to add p squared to both sides to get them on both sides, or to get it moved over. So I get 81 equals 3p squared, divide by 3, and you get p squared equals 27. We're going to take the square root of both sides to find p, which is the price that will maximize profits. So the square root of 27. All right. I don't say the price is going to be 3 radical 3. Okay. So again, love this button on the calculator. Hit the double arrow. So it's going to be $5.20. Now, this number makes sense. When we calculated at E of 6, it said you better lower your prices. That's lower than $6. When we calculated at $3, it said, you know what? You have a lot of give here. Raise your prices to build up your revenue. This is definitely more than $3. So that is what companies look at on setting prices.